Hey everyone, hope you're enjoying PlatformCon 2025. Welcome to the session on role of observability and platform engineering. Hi, this is Neel Shah, a DevOps community guy. I work as a developer advocate at Middleware. I used to host many meetups around DevOps in my local region, and I have managed more than 15 plus hackathons across India and have given talks in 15 plus conferences, including the KCDs and KubeCon. So yeah, going ahead, how do you see the rise in platform engineering and what is actually the platform engineering? Platform engineering enables us to build self-service, self-reliable internal developer platforms, that is IDPs. So if you see Gartner's report that Gartner predicts by 2026, almost 80% of the companies would have the platform engineering teams. So you can see how people, how the companies, how the organization are shifting and platform engineering space. And the next thing is rather than focusing on different things, platform engineering majorly focus around reducing the developer cognitive load and improving the developer experience. So the main goal behind platform engineering is to deliver faster delivery with higher quality and lower operational burden. To do the same task frequently, collaborating with other teams, and in a better way, in a more productive way. It helps a lot. Next comes what are the key principles of platform engineering? So it covers the developer self-service. It makes the developer teams autonomous to build and scale the platform, to build and scale their infrastructure. But it creates a baseline for everyone to collaborate with different teams. Next is it is API first design. It standardizes some of the interfaces for seamless integration with multiple tools. It makes a lot of automation, which is eventually helping out a lot of developers for their productivity. Next is it is observability always helps. I will cover most of the portion of observability in the next few slides. And obviously, we also track and measure what are the key matrices to identify improvement areas which are improved by this and which are going to be improved. So yeah, we take care of that. Going ahead about a lot of layman language in observability. What is observability? It is the ability to understand the internal state of a system by examining its outputs. You will be able to understand better what is actually going on inside an application from seeing the matrices traces log. Before that, we were using monitoring. The monitoring it was just alerts. Nothing we were getting insights from that. And then it came observability. So from the same data resources, we are getting much more insights. That is helping out for troubleshooting. Observability is helping out in a lot of sense. Observability is mainly have three main pillars that are matrices, traces, and logs. Matrices are like in quantitative data. You can see the matrices, dashboards, graphs sort of thing to better understand how much the CPU is utilized, how much performance it has consumed, or how much it has improved. Logs are generally like you have seen application logs, infrastructure logs, and many type different of logs you can capture of your services and different things and in their space. Now it is absolutely as a cornerstone. So how observability is helping out is it can help in proactive detection. It is helping out in faster analysis, so you can have better root cause analysis and have lesser time for getting out troubleshooting. Next comes data-driven decisions. So you have a lot of insights from your data that is you're storing in logs, metrics, or traces, and you are able to predict a lot of things. Next comes Observability's role in platform engineering. It provides real-time visibility in your system health and behavior, how your system, API, servers are behaving internally. It can help you out your platform to optimize resource usages from matrices of CPU, let's say application performance. You have matrices of each services, so you can better understand how the services are how services are utilizing the resources or the CPUs or the computes, and you can better understand and scale when needed. And you can also trigger out some of the alerts based on that. Next is incident detection or resolution. So it absolutely also helps, and it also alerts sometime when some of your APIs are getting down. So in observability, there is also one feature sort of thing where APIs can also be triggered. APIs can also be monitored. So if some of the APIs get down, then you will have an alert in your resource. Let it be Slack, Teams, or WhatsApp or email anywhere. It also enables the better developer support through transparency and service insights. It also helps out to drive some of the decisions from the data insights for platform improvement. And on the controversial, what platform teams gain. So we discuss how the opportunity is helping platform engineering. Now, like we'll see what actually the platform teams gain with observability. It is it improves the reliability. It detects anomalies earlier. I will also see how what is anomalies. The anomalies are basically it figure out some of your historical data and predicts if something is going to happen in next future or something. Next is faster troubleshooting. It reduces the mean time to roll back, and apart from that, it also helps us enhance developer experience. Also helps in data-driven decision making. Also efficient resource utilization. So to achieve effective observability, what are the major steps? First is you need to understand what are the high impact services for your platform or application. So you need to monitor, you need to implement observability in that portion. Next comes you need to help out all the team to adopt the platform or tool in a particular manner so they can get better understanding. Next is consistency and quality. So once you set up everything, there should be a standardized format and standardized things going on as a workflow that all the logs are getting there and you are getting alerts properly and everything should be standardized there. And next is it should be iterated and improved as in a feedback loop cycle. So eventually you will be able to observe all your services application in a proper manner and it will give you more insights. It will eventually help you to gain more productivity and work more efficiently. Let's say a normal case study. So for to be it's a case study around platform improvement, which a platform engineer also might be see. So challenges there are some of the slow database queries causing performance lag. So how you can improve? You can see some of the logs. Eventually, you can see the whole traces, and you can see the portion of that trace, the whole trace, where eventually it is taking longer time, which query is taking longer time. So observability helps here because you can see the traces in a like single line sort of thing, where there will be parent as span IDs, the child span, and they will be connected. You can eventually see which is taking how much amount of time in seconds, milliseconds, everywhere. It will eventually help you out to optimize that queries, and it can eventually help you to gain more results like this: 50% latency reduction, 20% increase productivity, and error rate declaration. So yeah, these are some of the use cases which are eventually helping out a lot of companies. Next thing is we need to balance observability practices for clarity, because if you have a lot of data and you're pulling out all the data in the observability platform, then it is not a good thing. Why? Because if we see a lot of data, then the team overwhelms. Yeah, we have a lot of data, we are getting all the things. But eventually, at a time of troubleshooting, a lot of data can create a mess and it will take a more time. So it is preferable to have lesser time, like have proper data in the platforms. And to enable effective troubleshooting, it is very necessary to have proper data and remove the mess or noise which are not necessary to keep your dashboards clear. So eventually, we don't need a lot of data. We need data in hygiene moment. Next comes the biggest thing in observability space is open telemetry. Why I wanted to tell you is before open telemetry, people were getting data from different sources, different applications, but they were in different formats. There was not a single standardized thing where if I want to change from this tool to this tool, I just need to import and export things. Previous to that, people were exporting data in JSON, YAML, and Markdown in different formats of data, and they were just getting on a single platform. But there was no standardized thing. If today some of the platform has shut down, and if I need to change to another platform, then it was not possible at all. And then came the open telemetry. So open telemetry is a standardized framework sort of thing for collecting your telemetry data from your application, and it is one of the biggest contributed project after Kubernetes in the CNCF landscape. So what are the key metrics to monitor? Majorly, what we see for AI ML projects are we see latency, we see inference time, API response time. We also see the token usages of LLM sort of thing. We also see how many errors are there, how many failed API calls are there, how many response inconsistencies are there. So what are the future trends in platform engineering with comparison with observability? So we need to stay ahead by adopting automation. We need to stay ahead by adopting AI-driven insights and enhanced security measures. So AI automation. Nowadays platforms are coming up with. So if you have some incident in your like application, so the observability platform will give you just need to click a single button and it will do the incident things and it will create if let's say one example. If your CPU is 80% consumed, so the monitoring platform will tell like you need to have like more CPU and it will give a prompt. It will give a button. You just need to click the button, it will increase the CPU. So in similar manner, automations are coming out. So you need to use that. You also need to integrate some of the threat detection sort of thing to prevent your data. And obviously, uh, both platform engineering and observability are nearby in cloud native space. So nowadays people are using microservices more, a lot of things. So it's that data. You need to also understand and switch on that. If you see the observability cycle in platform engineering, first is collect data, next is analyze data, gain insights from that, implement the solutions, monitor the system continuously to have feedback, track and system and also track the system health and performance. So it is a continuous loop. If you implement this in a better manner, it will eventually help you a lot. Auxiliary and platform engineering. So some of the core tools for system insights are in the middle of the things. Then you have latency detections, root cause analysis, anomaly detection, system reliability, a lot of things around observability space. Anomaly is like helping out in a lot of examples. Anomalies help out to pre like to prevent rather than to cure. So to help you to prevent and to take reactive steps before if something happens. So get a detailed understanding of all the concepts around of observability and platform engineering. You can scan this and there will be a blog over there. It's detailed blog on how observability helps in platform engineering. Connect with me for any queries if you have. I will be happy to help you out. Thank you for listening my session. Hope you enjoyed and have a good day.